Our topic today is trapezoids and kites, the last two of the special quadrilaterals we are talking about in this unit. Your learning target is to use properties of trapezoids and kites to solve problems involving quadrilaterals. Take a moment, please, and turn that into the essential question. A quadrilateral with exactly one pair of parallel sides is a trapezoid. The parallel sides of a trapezoid are called the bases, and a trapezoid has two pairs of base angles. Each pair shares a base as a side. So let's look at this particular trapezoid, which happens to be a right trapezoid. My base is on the top and the bottom. Very traditional elementary school presentation of a trapezoid. So this right angle and this obtuse angle form base angles, and this right angle and this acute angle are also a pair of base angles. The sides of the trapezoid that are not bases, the non-parallel sides, are the legs. If your trapezoid has congruent legs, it's an isosceles. I-S-O-C-L-E-S. I just misspelled that, didn't I? I-S-O-S-C-E-L-E-S. I-S-O-S-C-E-L-E-S. There we go. An isosceles trapezoid. Again, oriented the way you often see it in elementary school. Bases, congruent legs. A segment in a trapezoid that connects the midpoints of the legs is called a midsegment. You'll remember that back in the properties of triangles unit, we told you to be sure to call it midsegment of a triangle theorem because there will be a midsegment of a trapezoid theorem. But if I pick my midpoints here and connect them, that red segment is my midsegment. Finally, a quadrilateral that has two pairs of consecutive congruent sides, but the opposite sides are not congruent, is kite. These two sides are congruent. These two sides are congruent. Okay, but opposite sides are not. An interesting thing about kites, the angles between the non-congruent sides are congruent to each other. And if we drew with a diagonal right down the center, we would have side angle, side congruence on those triangles. Okay, no geometry lesson is complete without theorems, and here we go. If a trapezoid is isosceles, then each pair of base angles is congruent. This means angle A is congruent to angle B, and angle D is congruent to angle C. Okay, of course, watch the way we have oriented or turned your trapezoid so that you don't get confused as to which ones are the base angles. If a trapezoid has a pair of congruent diagonals, then it is an isosceles trapezoid. So if AC is congruent to BD, trapezoid ABCD has to be isosceles. A trapezoid is isosceles if and only if its diagonals are congruent. All right, so we just had the theorem and its converse forming a biconditional right here. Don't forget all of those statements from Unit 2. And ABCD is isosceles if and only if base angles are congruent. Another biconditional statement. Next, we continue with our theorems. The midsegment theorem for trapezoids. The midsegment of a trapezoid is parallel to each base. So this means that MN is parallel to BC, which is parallel to AD. And its length is 1/2 the sum of the bases. So the length of MN equals half the length of BC plus the length of AD. Now remember, your midsegment of a triangle was parallel to the third side and half the length of the third side. So these theorems are very similar to each other. If a quadrilateral is a kite, then diagonals are perpendicular. Which in this diagram means that AC is perpendicular to BD. Now I want to pause for a second and talk about what that means in terms of our kite. Right, we've got two pairs of congruent triangles. We have, and I'm going to call this point M. Right, we've got ABM is congruent to CBM. It's not difficult to prove. We have CDM congruent to ADM, also not difficult to prove. And then we have the large triangles on the top and the bottom of this kite, BCD and BAD, that are congruent to each other. Not difficult to prove. The smaller triangles, hypotenuse-like congruent. Right? I've got my hypotenuse, and here's my leg. So saying that CDM is congruent to ADM, hypotenuse-like congruence. Same thing on the other side. 1, 2, 3, 4. Hypotenuse and my leg. So saying that BCM is congruent to BAM, very quick and easy to prove. Watch out for that, because you know we like to integrate stuff from previous units. In addition, the diagonal that connects the non-congruents, because of those congruent triangles, these end up being congruent to each other. So, there's a lot we can do with kites, pulling in congruent triangles. Be prepared. If a quadrille is a kite, then exactly one pair of opposite angles are congruent, and it has to be the angles between the non-congruent sides. All right, so AB is not congruent to AD. Angle A is congruent to angle C. All right, at this point you're going to need another guiding question. Quadrilateral WXYZ is an isosceles trapezoid. Find the measures of angles X, Y, and Z. All right, well, base angles have to be congruent, which means the measure of angle W has to equal the measure of angle X, which is 110 degrees. So there's one of them, 110. Okay, we have parallel lines, which means I have consecutive interior angles right here, meaning they add up to 180 degrees. So 110 plus the measure of angle Z will equal 180 degrees. And the measure of angle Y is a base angle, and therefore congruent to the measure of angle Z, which is 70 degrees. Oh, that's the most beautiful word in the world. Prove. I know how much you love your proofs. Givens. Oops, sorry. Statements and justifications. So, my givens are all ordered pairs. H is at 0, 6. K is at 4, 8. J is at 9, 3, and I is at 3, 0. Givens. Okay, I'm asked to prove that I have a trapezoid. To be a trapezoid, I need exactly one pair of parallel sides. So that means I have to prove two sides parallel and two sides not parallel. All right, so step 2 is going to be my slope formula. And step 3 is to find the slope of all of these segments. So let's see, the slope of HK is going to be 8 minus 6 over 4 minus 0, it's 1/2. The slope of IJ is going to be 3 minus 0 over 9 minus 3, 3/6 is 1/2. The slope of HI is going to be 6 minus 0 over 0 minus 3, that's -2. And the slope of JK is going to be 8 minus 3, 4 minus -9, -5 over 5, -1. So I substituted and simplified my formula. So let's see, I need to, okay, in order to have parallel sides, I have to have congruent slopes. So let's see here. The slope of HK equals the slope of IJ. And the slope of HI does not equal the slope of JK. Substitution. This will allow me to conclude that HK is parallel to IJ and HI is not parallel to JK. Slopes of parallel lines theorem. Therefore, HIJK is a trapezoid. Definition trapezoid. Isn't it beautiful how that information from Unit 3, which is really from Algebra 1, comes back into play here as we look at a little introduction to coordinate geometry. You'll do a lot more coordinate geometry in the last lesson of this unit. All right, continuing with some practice problems. We're asked to find the measured angle S and the measured angle U. So as I look at STUV, I have a kite. I have two pairs of congruent sides that are not opposite each other. And I know in a kite, just drop my pen, in this one, S and U have to be congruent. Plus, this sucker is a quadrilateral, which means the sides add up to 360 degrees. So 360 degrees minus 73 minus 37, and then divide by 2. My two congruent angles are 125 degrees. If AC equals 38 and ED equals 41, find CD. Okay, AC equals 38. We know at this diagonal, the diagonal that connects the two congruent angles gets bisected by the other diagonal. I mentioned that back when I was talking about diagonals in a kite. So 38 divided by 2 is 19. And then we are told ED is 41. Diagonals in a kite, from our earlier theorem, are perpendicular. So this DC is my hypotenuse, and this is Pythagorean theorem. Right? C squared equals 41 squared plus 19 squared. All right, and we get a pretty ugly radical. Let's quickly see if we can simplify that. Divide by 2, 3, 4. 3 won't work. 4 doesn't work. 5 doesn't work. 7. 7 would give me 3, 4. Nope, 7 doesn't work. 11 doesn't work. 13, no. Okay, at that point I'm quitting. If I don't find it within the first few primes, I'm done. So we just have a pretty ugly radical there that cannot be simplified. All right, find the measure of angle FGI. FGJ. So we're trying to find this one, and we're given some interesting information here. Let's see. We know those diagonals are going to be perpendicular, and we also know that this diagonal between the non-congruent angles bisects the non-congruent angles, because we know that FGH is congruent to triangle FJH. That means 5x minus 1 equals 2x plus 11. So 3x equals 12, x equals 4. This angle, angle JFG is going to be 2 times 4 is 8, plus 11 is 19. So 180 minus 90 minus 19 will give me angle FGJ, 71 degrees. All right, another guiding question here. This one asks me about a trapezoid. I've got vertices, and I'm asked what formula would help me find out if this trapezoid is isosceles. And then, okay, so if I want to know if it's isosceles, I have to have a trapezoid, number one. So, and I have to have the non-parallel sides congruent in order to be isosceles. So I need slope to prove that we have non-parallel sides. And then I'm going to have to use the distance formula to prove the non-parallel sides congruent. And lucky for you, it just asked me how to do it. It didn't ask me to actually do it, so you're in luck at this point in the notes. You need a couple of guiding questions in the summary, and you are done for today.